Hey everybody, today we're going to be looking at 6.3. We're going to be doing Unit 6 a little out of order. We're going to be skipping Unit 1. Or Section 2 is graphing. Um, we felt like it would be better to do graphing after we've kind of looked at what these things do and how they act. That way you can get a better understanding of why the graphs work the way they do. So we're going to hold off on graphing for 6.2. We probably won't get to that until after Christmas. So the idea and the plan here is we're going to take 6.3. We're going to do it in one day. It's not too bad. 6.4 is a little bit more intense. So we're going to spend 2 days on that. And then we're going to look at 6.5, which isn't too bad. So we should be able to fit in one more test before the break, just as a heads up. Before we get into that, we're going to be looking at multiplying and dividing rational expressions today. So this is a unit that really freaks people out because they're fractions. The biggest tip I can give you for these is don't think of them as fractions. Think of it as division. That's all fractions really are. So doing these really quick, if I have multiplication with, again, rationals, let's not think of them as fractions, let's think of them as division. Multiplication is multiply straight across. So I'm going to take 2 times 5, get 10, 21. Okay, same thing here. I'm going to get 72 over 50. Okay, now it does ask me to simplify. I didn't have to simplify on this first one. It does ask me to simplify. There's two places where you can do this. We can do it before we multiply or after. Doesn't really matter. When we're dealing with variables, it's usually better to do it before. Honestly, with numbers, it's kind of better to do it after. So I can take a 2 out of both of these. And that's going to be it. So let's do that. So we're going to have 36 over 25. Okay, remember for division, we're going to keep the first one, flip the second one, and change the sign, KFC. Keep, flip, change. So I'm going to keep the first one, flip the second one, and then change the sign to multiplication. Okay, now again, I could go ahead and cancel here, but honestly with numbers, it's kind of just better to do it later. So 12 over 22, it's going to reduce down by 2, get 6 over 11. Okay, now for variables, same rules. Multiplication, we just multiply across. I do need to be careful that I keep the whole numerator or whole denominator together. So the best way to do this is honestly go ahead, anytime you see more than one thing, go ahead and put parentheses on all of them. It's going to save you a lot of headache later. Times 2 over 25. Okay, now here I would definitely check and see if you can cancel something. We can't. So I'm just going to distribute this 2. I'm going to get 2x minus 2 over 25. I'm going to hold off on the second two for right now. You'll see why later, because I'm going to actually go through the process on how to do those. One thing we do need to be careful of, though, with variables. We had issues in our last unit when we were taking the square root of a negative number. So there's two big times you have issues. So taking the square root of a negative number, and the other one for this unit, dividing by 0. So if those two things are happening, you've got problems. So we don't want to divide by 0. We don't want to take the square root of a negative number. Here we're going to be worried about that dividing by 0 for the most part. So remember, if I have something like, okay, so let's make it even simpler. Let's just say 1 over x. I have a problem if x is 1 or x is 0. If x is 0, then I'm dividing by 0. So x cannot be 0. Be any other number, not 0. Same idea. I can't have my denominator be 0. So my denominator cannot equal 0. So plus 1 plus 1. So x itself cannot equal 1. And that makes sense because if I plug in 1, I get 1 minus 1, which is 0. And this is a problem. Okay, so if I ever have something in my denominator, if I have a variable, let me be specific, a variable in my denominator, I always want to check for what we call excluded values. These are values that cannot work. Now, graphically, that can look like two things. And again, we'll get to graphically kind of later, but I just wanted you to kind of see as like a heads up what that looks like. So it can look like this, where there's a really obvious what we call asymptote there. It says, hey, x can't be this number. It will never be this number. It gets really close, but it can't be that number. The other one that's less obvious is where I have a hole. Okay, and we'll look at those more in 6.2 when we come back to it, but it's just something to keep in mind that that's what these things look like. Okay, so that being said, let's find some excluded values here. Now, if it's just x plus or x minus, we can do very similar to what we did before in our previous units with factoring, where we can just take the number, and change the sign. So like here, if I plug in, I have a -1 here. If I plug in a +1, that's going to be 0. So x cannot equal 1. And then for the second one, it can't equal -1. For this one, x, cannot equal 1 or 1, so really just 1. Um, for this one, x cannot equal 2. And don't worry about these. These I had to bring those in for another teacher. And -1. Again, just changing the signs. X cannot equal 1, cannot equal -2. Okay, now I need to be careful in these divisions. I'm gonna write these over here for right now. So looking at the initial problem, and this is where it gets kind of muddy, especially on these problems. Looking at the initial problem, x cannot equal -2 for both of these. Okay, and that's fine. But remember, this division really means that I'm going to keep, flip, and then change. So really, if I have division, both parts of the second rational are causing me problems, because once I flip it, now that x plus 1, instead of being on the top, is now on the bottom. It's now on that denominator. So now I've got an issue. So x cannot be -2 or -1 here. So there's really 3 places you need to look on division problems only. Okay, again, up here, this is fine, because those are multiplication. They don't flip, they don't change. So in my initial problem, I have problems with +2, 0. Remember, if x is by itself, it's just 0. If I flip that second one, I've now got a problem with this, so it's going to also not equal -1. Okay, last one, same thing. X cannot equal -2. +1, again, flipping it, or 0. Okay, so this is going to be very important once we get to section 6.5 when we're solving these, because what you're going to get is you're going to get those extraneous solutions, kind of like we got in the last chapter, where it's like, yeah, this answer works, but because of one of the denominators, I've got a problem and it doesn't really work. Okay, so make sure you are checking for that. Okay, now last unit I told you guys several times, or not last unit, 2 units ago, several times, that factoring was going to be probably one of the most important things you need to learn to make sure you understand. We spent a whole extra day before the break doing that. If you haven't got factoring down by now, you really need to be coming for RTI time and getting that extra help, because it's late at this point. I am not going to be spending a lot of time doing factoring, and in fact, most of the time I'm going to just skip the factoring part, because you should know how to do it at this point. The first step on every one of these simplify problems, so simplify tells us, hey, we want to try to get rid of stuff. Do not do this. And I want to be very clear, do not do this. If you have any addition or subtraction, you cannot just cross stuff out. You have to factor it first. If it's all multiplication, that's fine. But if there's any addition or subtraction, do not start crossing stuff out. So do not do this, where you say, oh, I have an x squared, I can cross it. No, you cannot do that. You must factor first. You can only cancel if you have multiplication and division. You don't have that here. So the first step on all of these is factor. When I factor this, and again, I'm skipping that because, again, you should know how to do this by now. You get this and this. Now I have multiplication happening. I have multiplication happening here, and I have multiplication happening here. That first term is multiplying to that second term in the numerator. Same with the denominator. That first term is multiplying to the second term. So now I can cancel stuff out. So I can take this x plus 2 and this x plus 2 and cancel them. And I'm left with x minus 6, x minus 2. Now again, we cannot cancel these x's out because there's subtraction happening between them. So this is my simplified answer. Okay, now if I needed to show excluded values here, my excluded values would be -2 from the first one, +2 from the second. So for simplifying, factor it, and then cancel out what you can. That's really it for those. Okay, so some of these will already be factored, like that first one. So multiplication happening, I can cancel these out. Can't really do anything with the rest. So then that's going to be it. Again, my excluded values here, if I needed them, you don't always need them, would be -1, -3. Okay, again, this one doesn't look like it can really do much. Don't do this. Can't do that because we have addition and subtraction. X plus 4 is already in a factor. And then we're going to have x plus 4, x minus 4. So the plus 4s cancel out. Okay, now remember, I still need to have something up top. So I'm going to put a 1 up top. Okay, one of the most common mistakes is students like to write just x minus 4 because everything else canceled. Don't do that. X minus 4 is in the denominator. It needs to stay there. Okay, this is my solution. And then 4 or -4 would be my excluded if I needed it. Here, can't do anything. So I'm just going to leave it. Here, this factors into x minus 3, x plus 1, x minus 3, x plus 2. Okay, so the x minus 3's cancel. I'm left with x plus 1 over x plus 2. Okay, can't cancel out those x's, can't do anything, so I'm done. And my excluded values here would be 3 and -2 if I needed them. Okay, so simplifying is fairly simple. It's not too bad. Multiplication isn't much worse. Okay, now I do need to be careful here because right here, I don't have any addition subtraction, so I can just go ahead and start canceling stuff. If you don't have factors, honestly, it's kind of easier just to do it at the start, but really it's up to you. I like to kind of cancel at the start. It could go either way, depending on how it kind of falls. Let's go ahead and actually put everything together and go from there. So 8 times 7 is going to be 56. X, okay, I've got 3, I've got 4, right? So x to the 3 times x to the 4, y to the 1, y to the third. Multiplication happening between everything. 2 times 4 is 8, x, y cubed. Okay, so let's combine some of the stuff on the top in the numerator. So 56, x to the 7th, I'm multiplying so I can add product rule. And then y to the 4th over 8, x, y cubed. Okay. 56 and 8 can reduce down by 8, so I'm just left with 7. I have 7 x's. I have 1 x down here. Quotient rule says I can subtract those. So we get this. And then here, same thing, 4 minus 3. Okay, so everything in the denominator there cancels, so I'm actually just left with this. And again, you could do that here where you say 8, 4, 2. Those all kind of cancel. This cancels with this, so I'm only really having x2. And then you could say this cancels with this, but I still have a y. This cancels with this. And again, it doesn't really matter if you're comfortable with the way I did it first, do it that way. For the next one, okay, now we have those plus minuses. These are the ones that you're going to see more common. They're the ones you see most often. It's honestly, you don't see a ton of these. They pop up on ACT every so often. These are the ones that they really like. First step, factor. Okay, if you see any addition or subtraction anywhere, factor. Okay, so I can take a GCF out of this first one, 3x, x minus 3. Denominator is going to be x plus 5, x minus 1. Numerator here is going to be x plus 5. Oops, sorry, not 4. X minus 4. Okay, now at this step, if it's multiplication, just put it all together. Remember, multiplication just multiplies across. So step 2, put it together. Step 3, cancel. So we want to cancel anything out that we can. So looking at this, I've got a 3x here and a 3x here. I've got an x plus 5 here, an x plus 5 here, and then nothing else cancels. So then write what's left. So x minus 3, x minus 4 over x minus 1. Okay, now as an ACT trick and an ACT tip, you may see it where you need to recombine things. You get to this point, you don't see your answer. Okay, it's not that you did it wrong, it's that they have it written differently. Okay, so you may need to, on that numerator, recombine things. So you may need to combine this back into, it would be x squared minus 7x plus 12 over x minus 1. Okay, so it's just something to keep in mind for like ACT, just in case you ever see it where it doesn't quite match up to what you got. You did everything right, you just need to get it in the right form. Okay. So for product, if it just has multiplication, I would honestly probably just multiply everything together and cancel. And then here, factor, and then cancel. Let's do number 6 again. Those are the most common ones. So I want to take a GCF out of that first one. The denominator is going to be x minus 5, x plus 5, x plus 3, 2x squared. Now that squared is going to be important in a second. So the 2's cancel. I have 1x, I have 2 x's. So this x cancels with one of these x's, but I still have an x left. Let's put parentheses around that. X minus 5 cancels. So I'm left with x plus 3. And then let's put this x in front. Doesn't really matter because we're multiplying it, and multiplication is commutative, so I can move it around. And then this is going to be my solution here. Okay, one last thing we need to look at is division. So the only difference with division is that we need to do that KFC, the keep flip change. So 7x, 2x minus 10. Okay, now I would go ahead and flip it first. It's going to be your best bet, actually. So step 0, let's say, is going to be to do that KFC. And the reason for that is you're not going to try to cancel something too early. Okay. Now from here, we do want to factor, and we're just going to follow the same steps we did with multiplication, because now it's just multiplication. So we're going to follow the same steps. So 7x, I can take a 2 out of this as a GCF. This one is going to be x minus 15. No, sorry. Let's actually do this one real quick. So 30, negative 11. It's going to be 5 and 6. Okay. Sorry, went too fast. Ooh, nope. Go back. What is it? Sorry. Undo. There we go. Sorry about that. So it's going to be x minus 5. Sorry, I needed to do an extra step there. And x minus 5 over, take an x out of this, GCF, x minus 6. Okay, so thing to watch out for on these problems. If you ever get to something and nothing cancels, you factored wrong. Okay, the chances of it nothing factoring and nothing canceling on these is almost zero. So if you get to the point where you're canceling stuff and nothing cancels, double check your factor. Just as kind of a quick tip. Okay, 7 and 2 can't do anything. The x's can cancel. The x's minus 5s can cancel. The x minus 6s can cancel. So actually, this one is kind of an interesting problem because it just goes to 7 point over 2 or 3.5. Okay, and that's really it. Like, I mean, that's about as hard of a problem as I could do. The only thing maybe more is like something like that where I need to add the 1. But really, these are all the same. The division ones, there's just that extra step where you need to flip. Okay, now make sure you are watching for those excluded values if it's asking for them, but I don't think we included too many of those. It's mostly the ones where you're actually performing the operation. So that's it. Make sure you're showing up for tutoring RTI time. If you're in my virtual classes, do your work, show the work, no credit. I'm still having people not turning in work. Please make sure you're getting that done. If you have any questions, feel free to reach out to me, and I will see you guys next time.